This conference will now be recorded.
Good
Can you all see
morning.
the screen and hear me?
Yeah.
Please keep muted, all of you. Hello, everyone. Good morning once again. Thank you all for joining the class. Yeah, there are many new joinees today. So yesterday, the first demo class is nothing but an overview of DevOps, the theoretical part. You can also watch the recording session. Today, we'll be starting with the first tool in our course, which is Git. Okay, any questions you have, anything else, any concerns, anything you want to talk to me, we shall discuss at the end of the class. Yes, class recordings will be provided. Whoever were joining today, as a first class, I'll provide you the demo class recording where we have gone through the overview of DevOps. So let's begin with the first tool in the course. I believe you all can hear me. Am I audible for all of you? Am I loud and clear? So please keep muted unless you have a question, please keep muted. If you have any question, unmute and speak out, or else you can put your message in the chat window also. Otherwise, please keep muted. So now let's get started with the first tool in our course, which is Git, a version control system. We'll be going from basics. Every tool, any concept in this course, we'll be dealing from the basics till advanced concepts. Okay, we'll spend some couple of days here, maybe 5 days or so on each tool. At least Git will spend at least 5 days. Okay, so let's begin with this. So first, let's learn what is a version control system. Why do we need it? Who uses this version control system? Yeah, let's see. Basically, version control system will help you manage your huge set of files. To understand this better, let's take a simple example. Let's imagine there is a project. Okay, let's talk about what a version control system is. Let's say there's a project and there were so many files there. Your files could be anything. There might be some configuration scripts, there might be some script files, there might be a code, whatever it is. Okay, let's say this project is having some hundreds of files. Okay, and on this project, multiple people may be working. Let's say DevOps person 1, DevOps person 2. So many people are working here. And let us take another example. I mean, let's say, okay, there is a file here called script1 or else some configuration file. Person 1, person 2, both of them have to work on the same file. Okay, so this person, DevOps person, first person, get this file to his local computer. All this project files, all this code base is on some remote location where these developers or DevOps person can share it. So this both person 1, person 2 got the files to their local computer at the same time, made some changes to this file. He made some changes in his local computer. Developer 2 kept this file back. Okay, first he kept this file back on, let's say, Monday. And then on Tuesday, developer 1 kept the file back. Okay, now the script file or configuration file is available on this location. Now this file will have which person changes? Will it have person 1 changes or person 2 changes? Let's understand the importance of version control system with the simple use case. This is some repository or else the code base, the program files or else the configuration files are available here. Okay, let's say there is a file called p1.txt, some text file. Both the persons are working on it at the same time. Both of them got it downloaded to their local computer, made changes. So developer 2 kept the file back on Monday. Developer 1 kept this on Tuesday. They have made some changes in their locally and then moved it to remote. So now the question is, this file will have which person changes? Anyone? What do you think will happen? A simple logic, a general scenario. What happens now? This file on remote will have which person changes? I'm talking about without any version control system. They were not using any version control systems. Generally, what happens? Yeah, tell me please.
Second person.
Second person changes will be there because Sorry, see, developer 1 kept the changes back. Developer 1 changes will be there, isn't it? See, first this person got the file to his local computer, made some changes, then put it back. Then this person placed his changes. What happens? Developer 1 changes will be overwriting the changes of developer 2, isn't it? Because developer 2 kept the file back first. Then D1 kept his changes. So D1 changes will override D2 changes, right? If this keep on continuing, always overwriting may happen, project may get messed up, project may get corrupted, right? Because there might be some 10 people in a team. Each person may be overwriting other person changes. Developer 2 doesn't know that this is happening. Even developer 1 doesn't know he's overwriting. This happens because there is no tracking, there is no proper versioning, right? How to overcome this? That's where version control system comes in. This version control system will help developers or any team to work parallelly. They can work on the same file, but it will not overwrite, rather will inform them. Already some changes are there, do you want to overwrite? So it allows teams to work simultaneously, right? Because in a huge team, each person will be working on his own files, on his own code. He cannot just go and check whether his changes were saved properly, were secured properly or not, isn't it? So they cannot do this manually. Version control system comes in rescue. Not only that, let's take another use case. Suppose application is working fine, it's already end users are using it, it is doing fine. Suddenly application crashed at, let's say, 7:30, application crashed. Okay, you want to immediately identify the changes and remove them so that the system will be back in 5 minutes and it should be, business would be up, right? How do you know what happened in between? Till 7:20 it was good, something happened in between this 10 minutes. So if there is a system which can provide detailed logging at 7:25, person A, some developer A or whatever, some DevOps person, whoever it is, some person made some changes to p1.txt in line number 9. So if you have this kind of detailed logging, what is meant by logging? Tracking the changes, right? Like you need to have the history of the changes, which person made the changes, on which file, on which line, at what time. If you have this kind of detailed logging, obviously you can identify, remove these changes so that the system would be back, correct? So how can we achieve it? Again, version control system does that. It will have a control on which person is changing what at what time. Such a detailed logging with a timestamp help you manage your projects effectively, right? That's another use case. And let's talk about another scenario. Suppose, let's say person A is working on some configuration file, some script. Okay, he made some changes and it's a version 1 of this file. Let's say, okay, let's say it's a p1.txt version 1. Client came with some modifications. They want to include certain script, they want to include certain logic. So let's say this developer A, what he does, he has deleted this file or edited the same file and made another file. He just edited the same file and made it v2. He don't have this old version now. So again, after 6 months, if new versions are not doing good, client want to go back to the previous version, but we have deleted it or overwritten the same one. Don't ever do that. Maintain versions. You should have all the versions of the same file. Old version, 6 months back, how it is. You should have complete versions. All of them cannot be done manually. That's where version control system comes in. So basically what a version control system does, it can help you manage your files in your project. In your project, multiple people might be there, right? All these files should be version controlled, should be tracked, should be secured properly. That's what version control system does. It allows people to work simultaneously. It helps you have a detailed logging. It helps you have a backup and maintaining the versions. All of them are taken care by a version control system. So now who uses it? Developers uses it. It's mandatory for developer, because developer write so many program files. Definitely it's a mandatory tool for them. And also QA people, testers uses this, because They write some test scripts, automation test scripts, test case, so many files need to be version controlled. So they use it. Even DevOps teams use that. We may have so many config files. We'll be also using some Ansible configuration files, Terraform files, and so on. All these files can be version controlled. So everyone in IT should know this version control system. Okay, to manage our projects effectively, efficiently, we should know this. Everyone should know this tool. So we'll learn this tool from basics till advanced concepts so that you can clear any question on Git. You can answer, you can crack any questions in the interviews regarding it. Also, once you learn this Git in with respect to how to version control your files, we'll also then use or learn this Git to integrate in the delivery pipeline, CI/CD pipeline with the DevOps approach. Okay, first we'll learn it and then we'll integrate in the delivery pipeline and see how we'll use it in the DevOps approach, right? So this is what version control system, and this is how people use. So again, these files could be any files. They might be Java files, Perl scripts, Python scripts, Shell scripts, some .NET, whatever it is. Developers may be using some program files. QA will be writing some test scripts. Like I said, it might be YAML files for Ansible, Terraform, whatever it is. Any file can be version control. So now our agenda is not to learn all these languages. Our agenda is to learn version controlling any file. So we'll use some basic text files and we'll learn version controlling them. Later on, as we go with the course, we'll be version controlling Ansible, Terraform, all the files. You can implement them to any files, right? So now that we understood what a version control system is, let's try to understand more about this. Yeah, so we have understood what a version control system is. Now let's talk about how they were categorized. Version control systems were categorized into two types: centralized version control system and distributed version control systems. Okay, so what are the centralized and distributed? Depending on the architecture, they were actually categorized. See here the architecture. If you see the architecture here, central version control system means there is a central server or a central repository or a remote server, whatever you call it. Okay, here we keep all our files, configuration files if it is a DevOps person, or program files if it's a developer, whatever it is. All the program, all the project files will be kept here. Now, if you see here, this is a workstation of each individual developer or a DevOps person. Okay, so all the project work is on remote. Okay, how each person will work? Let's say there's a DevOps person one. He will connect to this remote and get the files to his local, work on it, put it back. The same way every person will connect to this remote repository and work on it. This kind of architecture is called central version control systems. And there are some drawbacks with this kind of architecture. First drawback is always network connection should be there to work on it, right? This is some remote server. This is some remote server. So we should always get connected to it to work on it. For some reasons, if network is disconnected, entire work will be halted. You have to wait till your network is restored. Okay, that's one drawback. Another drawback is this is like a central or a remote repository. It works like a single source of truth. For some reasons, if this central server is gone or lost or crash, entire repository, it means entire changes are lost. Chances of recovery are very less. So these are the two drawbacks of centralized version control systems, right? To overcome these drawbacks, we have got distributed version control systems. Distributed version control system architecture is a bit different, which overcomes the drawbacks of centralized version control systems. Okay, let's look into this, how it works. And yeah, in the modern DevOps projects, this is how we are using. We'll use distributed version control systems more. And see here, yes, you have got a central server again, and this is the workstation of each individual user. Okay, every individual user, if you notice, this is the workstation of each user. If you notice, yes, he is having a copy of this remote repository called as local repository. This is remote and this is local. So every user is having a copy of a remote repository which is called local repository. Means this remote repository is distributed across, and he will not directly work on local, rather will work on something else called working copy or working directory. And once my changes are done, means imagine it's another folder or directory, you make your changes here, move them to local, from local you move them to remote. Means it's a 3 steps before changes goes to remote. Okay, first you work here, move them to local, then to remote. What is the advantage of it? There are many advantages. See here, majority of the times we work here. Only once complete work is done, you push, or push and pull commands are less frequently used. Once complete work is done, we'll pull to remote. We push to remote, right? Unless you push your changes, they are confined only for yourself. Others cannot see. Only once you push your changes to remote, others can see your changes, right? So they are less frequent. Means majority of the times you work here, so you don't need to have network connection always. You need network connection only to pull and push, right? Or even though there is no network connection, you can still continue working on local. Work is not halted. Once network connection is restored, you can push to remote, right? So that's how it doesn't depend on network connectivity. You need network connections only to push or pull, and that's how it overcomes the drawbacks of centralized. And the second thing is, because majority of the times you work on your local system, it is just working with your hard drive, right? So it is also faster. Always network connection need not be there. You need network connectivity only to push and pull. And also, even though this central server is lost or crashed, chances of recovery are more because every user is having a copy of it, right? Thereby it overcomes all the drawbacks of centralized version control systems. Modern projects of DevOps prefer this distributed architecture, and our Git falls under distributed version control systems. What are the examples of centralized version control systems? Other tools like SVN, TFS, these are all different version control systems which follows centralized architecture. All these comes under centralized version control system. Distributed version control system, Git is distributed in architecture. Git, Mercurial, Fossils, these comes under distributed. And we are learning Git, which is very widely used in the projects. Understood till this much, all of you? Any questions? Anything should I repeat? You can unmute and confirm me or use the chat box to confirm. Clear, everyone?
What if the local working system, like working copy respiratory is crashed?
If this is crashed, changes will be gone. That's why whenever you make a potential changes, we'll push to remote. Okay.
Okay, ma'am. Thank you.
Any more queries? So we understood what is a version control system, who uses it, and this different types of version control systems like centralized, distributed. Just let me summarize. We have discussed what is a version control system, right? Who uses it? Okay, and then we have discussed about centralized version control system architecture, distributed, and examples for it. Here, SVN TFS follows centralized architecture. Git Mercurial follows distributed architecture. Now we are learning Git in this course. So here we have seen the generalized architecture. Now we shall talk about the architecture of Git in particular. Okay. Yes.
Could you explain the definition of VCS once?
Version control system is a tool which will help you manage your program files or manage your code base or else manage your files in your project, because those files may be scripts, configuration files. Any files can be version controlled. Version control system is something which will help you secure your files, store your files, maintain your files, maintain versions of your files, backup of your files. That's what version control system does.
Good, thank you.
Okay. Yeah, and see here the graph. Like I said, when you compare Git with other version control systems like SVN, TFS, fossils, see the blue graph is for Git. Git is clearly the winner in the category. Okay, it is very widely used than any other tools. Right? See here, it is very widely used. When you compare the other tools, this is a Google Trend report, okay, where you can compare their usage, how widely they were used. Okay. So Git is very widely used. And yeah, now let's get into the architecture of Git in detail. Yeah, like I said, it's a distributed architecture. So like we discussed, yes, there is a local repository and there is a remote repository in Git. Okay, in local, again, local means this is your local computer, local workstation. So here there will be something called local repository. You directly don't work here. Like I said, we work on some other folder, some other directory here. Here we actually work. Once you have done the work here, it is not that you straight away push the changes to this local. No, you cannot do that. This is not allowed. Rather, there is another layer called staging area or virtual area. Okay, this is the Git architecture. There is something like staging area or index area. This is called staging area or index area. This is a virtual layer. Okay, it's not any folder. Okay, just a virtual layer. So what you will do, once you make your files here, once you are ready with your files, you will first put them into staging. How do you put? Some commands are there. We'll learn the commands in the demo. We'll go through complete hands-on on it. So let me give you an overview theoretically. Then I'll show you this architecture practically. So you move your changes to staging area. From staging area, you move your changes to local. Right? That's how you push your changes from working directory to local, from local to, from staging area to local. Once your changes are there in local, then you move them to remote. Okay, it's like a 3 steps. See, that's called Git tree. It's a 3 steps before your changes goes to remote. Okay, and yeah, you might be having a question here, like why do we need this staging area? Has it got any importance? Isn't it? Why do we need it? Correct? So let me tell you, this staging area, that's the architecture of it, and the importance is this staging area works like a preview or else pre-check before your changes goes to local. And also this helps you, this layer helps you have a better control on which files you are moving to local and remote. Means it basically it helps you have better control. Yes, Priya, which part you want me to repeat? See, here I'm
The
repeating.
process, how you move it to the local rep.
How we move, we'll be using some commands. Okay, we'll learn those commands. We'll do that on the demo. Just I'm explaining what is happening. How do we do that? We'll do the demonstration on it. Okay. Just understand, here are your files. You create your files in some directory. Then you move to your staging area. From staging area to local. Okay, so this is how you move your changes. Means this staging area works like a preview or else a pre-check. Means, let me give an example. Suppose there are 10 files in my directory in my folder. I just want only 5 files to put it in the local repository. Only 5 files were ready. What you can do here, you add only those 5 files to the staging area. And whenever you run some commands like commit command, those files will go to local repository. Means you can have a better control on the changes before you move them to local. That's how the staging area or the virtual layer will help us. Okay. So how do you move these changes? How actually you will have a control? We'll have a demonstration on it.
When a commit is applied after the push pull or after add or all cases?
As of now, I'm not talking about any commands. Okay, ignore these commands. What I said, just whenever you make your files, first we should move to staging area, from staging area to local, from local to remote. How, what commands, we'll learn them. Okay, just understand the conceptually, okay, before going to the demonstration. So that's about staging area. And let me tell you few important things here. Yeah, here is a local repository, right? This is in my local computer. Listen here, these are a bit interesting and a bit tricky things here. Listen carefully. So how do you create this local repository? Local repository means which resides in your workstation, in your local computer. This local repository can be created in two ways, means two use cases, two scenarios are there. Assume that you are working on a project, you joined the company, you joined a new project. Okay, so already project is there on remote. Okay, it's some 6-year-old project, already project is there on remote. So you can copy from remote and create a local repository. This is one use case. Another scenario could be it's a completely new project. Okay, a new team is started, new DevOps team is started, it's completely new project. There's nothing on remote. So what you have to do, you have to create local repository manually, create an empty local repository manually. Okay, prepare your files, configuration files there, then push to remote. This is another use case. Understood the both, everyone? How it goes to local, all of them will see, Harish. Okay, how it goes to remote, how we'll do with the demonstration. Just understand the process, concepts. How I'll show you in few minutes. We'll go to our lab today. Okay, so first scenario is already remote project might be there. You may copy it and create a local. That's one way of creating local. Another way is there might be nothing on remote. Okay, it's a new project. So you may have to create local repository then push to remote. Understood the two use cases? Both of them I'll show you. Practically, we'll see both of them. First, we'll start with this. Assume it's a new project. There's nothing on remote. First, we'll do this. Is this much clear, everyone? Conceptually, if you understood, please confirm me. Theoretically, I'll show you in, practically, we'll demonstrate it in few minutes.
Preeti, I just have one question here.
Yeah, tell me.
What if two developers making changes on the same file at the same time and then pushing code to the repository one after the other? So this will be sequential changes, like the latest changes will be replicated to the repository, right?
That is
How you
without
expect it?
version control system. If you don't use version control system, one person changes may be overwriting other. But we are using version control systems. No overwriting happens. Overwriting will not happen. So how it handles? It will handle. It will inform us about the changes. Okay, how and all these scenarios we are going to demonstrate. Okay, just explaining theoretically will not do. I'll show you all of them. Okay, we'll execute those scenarios. When you say copy, you mean to clone it. Anil, yes, but I'm not using any technical terms here because we didn't learn any command yet. But correct. Okay, once we talk about the clone command, we shall discuss that. Local repository is nothing but a copy of your remote repository which resides on your local computer, Anita. Okay, I'm repeating again. See, local repository means a code base which resides in your local computer. Okay, this can be created in two ways. Like I said, you are a new joiner to the project. Already project is there on remote shared location. Everyone can create a copy and create a local repository in your system. That's one method. Another method is, let's say there's nothing on remote, it's a new project. You create local repository manually, develop the programs, develop the code base, then push to remote. Okay, it's nothing but a bunch of your project files. Your project work is your local repository. Okay, So that's about the architecture, but how do you push that? What is local? What is staging? How do you create them? All of them we shall do the demonstration. Let me tell you another interesting thing here. See, till now I'm talking about working directory is a separate folder, or else if you are a Linux person, it's a separate directory or folder, whatever you call it. And this is a separate directory, right? But let me tell you an interesting point here. This local repository, this working directory are physically one and the same directory. Means imagine in your system it's the same folder. Then how come you say it's a working directory, staging area and local, isn't it? Let me tell you. Logically they are different, meaning let's suppose this is a folder. Okay, this is my local repository, or else this is my working directory. Now just I have created a file there. If you just created a file there means that it is in your working directory. Okay, then after creating the file, if you run a command called git add that file name, then it is set to be in the staging area. Then again, if you run a git commit command, then only it's set to be in the local repository. That's why, but see, physically it's in the same folder. Logically it's different. That's why in the architecture we'll see that as working directory, local repository and all. Means just imagine they overlap one another. It's the same folder. Got it, all of you? Just place a file there. Just create a file there means it doesn't mean that it's in local. You have to first put it in the staging area. Otherwise it is said to be in working directory. You have to run git add. Then only it goes here. Then only it goes here. Understood this logic, all of you? Interesting, isn't it? This will be really interesting.
Priti,
Tell me.
Priti, I have one question here. So you mean that the file which is already committed, as a Git committed, that file will be only pushed to a remote for echo, right? The
Correct.
desktop file will be not pushed, right?
Correct. What, like, see this diagram. From working directory, you have to move to staging. From staging only local. You cannot do this straight away. Similarly, whatever in local, they only goes to remote. You cannot just do this directly. From staging to remote, no. Understood? Means it's like a hierarchy or a steps. How your changes goes to the different areas and finally goes to the remote. Got it?
Yes, ma'am.
Understood this, everyone? So now it would be really interesting to see practically how come it's the same folder working as working directory, staging area and local, right? So let's get started with the lab. Can I go for the lab or any questions? Anything
Yes.
should I repeat?
SA means SALR means
Staging area, local
staging.
repository,
Local area.
working directory.
Thank you.
From remote we can copy direct or other or their commands. There are commands we have to use, Harish. How to get a copy from remote and all, everything we'll see, but step by step. Okay, we'll go in a sequence, in a structured way. Git will be really interesting. Okay, you can enjoy working with it if you have these fundamentals strong. There will be people working on Git repositories, all advanced concepts, still without having clarity on this part. So it makes Git very complex and difficult to use in that case. Learn from the basics, have your fundamentals clear. You can enjoy working with Git. You can clear all the interview questions on Git. Okay, so now let's go for the lab. Okay, we have understood now everything about a version control system theoretically. Let's see practically what is the staging area, everything. Okay, and before that, one more thing. Git can work on multiple operating system. Git works for Windows. It can also work on Linux. It can also work on Mac. Okay, so you can choose any operating system to work with Git. Say the commands will be same. Even though operating system changes, commands will be same. Every command, concepts, everything is same. Only installation steps may be different. That's all. So particularly if you take other tools like something like a Docker, Ansible, definitely Linux environment is required. But for Git, you can use any operating system. I will suggest to use Windows for Git so that you first learn the tool. Once you learn the tool, you can apply the same on Linux or any other operating system. Okay, so we'll install Git on Windows and we'll work on it. We'll also see Git on Linux also. Okay, first let's start with Git on Windows. Go to your Windows, first install Git. Go to the browser, type in Git download. Okay, all these are open source tools. When you do Git download, you can see downloads, the first official documentation of Git, which is Git SCM. Okay, see here, you can download it on Mac or Windows or Linux. As of now, go here for Windows. Once you go there, you will see the download options. Okay, click on this. As per the bits of your operating system, download, click on this, or else you can also click here. It will download an executable file. Okay, I believe you all know once an executable is there, you just run the executable file. You all know that, right? So download the executable and run the executable. Just give me 1 second. These documentations, installation steps, everything were there in the drive. See here, this documentation is available in the drive. Everything, whatever I'm doing, just download this Git and see you can run the exe. See, once you download, you will get some executable like this. I have deleted it. Git. Yeah, here it is. Okay, so this is how you will see an executable. Just double click and open it. Okay, it will take you through the steps like next and all. It will have your wizard launched, and once the complete process is done, Git will be installed, and you will also see a component called Git bash installed. Do you see that? Go to your start menu and type Git bash. Okay, you will see this Git bash terminal means this is a terminal which provides some bash environment. Okay, just you can launch it. Okay, Git is installed. To check, run the command git version. So Git is installed. That's all. Git installation is very simple. Download the exe and double click the exe to run that. That's all. So finally, okay, Git is installed. And what is this Git bash? Git bash provides you some command line experience in Windows. Means, see, you can use Git in your Windows, and okay, Git is installed on my system. I want to version control some folder. Means I may put all my program files, project files in a folder, and I want to version control it with Git. So you can just go here, create a folder this way, new folder, and do it, right? Or else, rather than using this GUI, Windows have got this graphical user interface, right, where you create the folders by double clicking. If you want to go to your folder, you double click this way and do it. But you can do the same through command line. Command line experience is much preferred in real time because it makes the things more effective. And also in Linux, we don't have graphical user interface at all. We use command line, isn't it? So let's have some command line experience here. Are you all aware of this command line? How to work with the command line in your Windows? Let me show you a simple command so that you can manage your files and folders from your command line. PWD, a small command, right, which will show you. PW means present working directory. Working directory means how do you know where are you in the command line? See, it shows you where are you. Okay, and here on the desktop, I just want to create a folder. You create this way, right? Let's say my folder. Okay, how do you do that here? 1 minute. Just copy this path. If you want to go to any particular path in your Windows from the command line, cd means change directory, paste the path. Okay, and if you want to see here, you can see you have moved to this. Okay, present working directory is this one. Means I'm in this particular folder. ls is another command which will list everything in the directory. There is no files here, right? So these are the simple commands which helps you work in your navigate through the file system of your Windows. Yeah, say I'm in this my folder. Let's suppose maybe I just want to come out of it. Means I just want to click on this back. In the GUI, you just click on it, right? But from the command line, cd ... means it will move one level up. See, I'm on the desktop, right? So on the desktop, if you just want to see all of them, ls will list all the directories, folders present in there, right? Now, if I want to go to this folder, cd my folder. Simple commands to navigate from your command line. Okay. Now, similarly here, let's suppose I just want to create some file here, because files are the ones we are going to version control, files and folders, right? So now I want to create a file, touch file1.txt. Otherwise, from the GUI, how do you do that? Right click, you can create some file, right? Whereas from the command line, you can do this. See at the back end, do you see file1 is created? Yeah, I'm just showing you both of them together so that you can understand these simple commands easily. Okay. So anyway, yeah, this is a simple command line experience through Git Bash. Now, okay, fine, we have installed Git. Let's say I want to version control a particular directory. Let's suppose on this desktop, I would like to create another directory on this desktop and I would like to version control it. So how do you create a directory from command line? Make dir. These are all simple commands. Through little practice, you can remember them. Let's say I'm going to create a directory called git demo. See here, git demo is created at the back end. Now I would like to go there. cd git demo. ls, no files are there. Okay, fine. Now I want to put my project files in this git demo and version control it with git. So whichever directory you want to version control, you have to tell Git, okay, Git, please version control this directory. How do you do that? By running a command called git init. Git is installed on the server, but whichever directory you want to version control, go to that directory and run the command git init. So Git will be starting version controlling everything in this directory. Initialize Git. See at the back end, it has created a hidden folder called .git. Do you see that? .git is there means this Git demo is nothing but a local repository. Local repository is created. If you remember, I just told you some time back, local repository can be created in two ways. One is create an empty local repository manually. That's what I did. Means whichever directory having .git means that is your local repository. Understood, everyone? Now, if I put any files in this Git demo, all of them will be version controlled by Git. Understood till this much, everyone? Anita, Navya, all of you?
Yes, Preeti.
Okay, thanks for confirming. I'm expecting response from all of you. Okay, so yeah, this is going to be my local repository. Okay, fine, local repository is created. But where is the staging area, working directory, isn't it? Let's see. Let's create some file here. Okay, you may just go here, right click, create your files. That is also fine. Whatever method you create, either from GUI or from UI. I prefer UI. From UI, you can create a file with a touch command, or else you can use some editor like Vim. Vim is an editor. Okay, Vim file1.txt. Or else, see, if you feel like I don't know this Vim, I don't know, you just create it from the UI. That is also fine. We'll learn this Linux basic commands later. You may just go and create it. Don't worry about Vim and all. Our idea is to use Git. So Vim is an editor in Linux. You get this by default. Vim file name. See, it will open an editor. Now it is in the command mode. Command mode means I cannot type anything. What you have to do, escape I. Escape I means it goes into insert. Now I can type anything. This is my first file. How to close it? How to save it? Again, escape colon WQ exclamatory means save and close the file. That's all. File is saved and closed. If you want to open and just check the content, cat. These are a simple Linux commands. With a little practice, you will be fine. See, file is created. If you don't want to use it, just open the file manually. And whatever Linux commands I'm using, those are also there in the Google Drive. Okay, Linux commands document is there. You can keep this document beside and do the hands-on. See, PWD, what is meant by PWD, what is meant by ls, everything is there. How to create a file, just all these commands we'll learn later. Okay, Linux we'll learn separately. How to use Vim, press I key means escape key, everything is there. Okay, so don't worry when you do hands-on. Okay, anyway, file is created. But now let's talk about Git. Okay, file is created. Is Git version controlling it? Is Git version controlling those files? Let's see. Run the command called Git Status. Git Status will tell you what Git is doing or what is the position or what is the status of your files. See, just ignore these for now. See here, untracked file. There is a file. Listen here carefully. Git knows there is a file. Okay, Git know, okay, there is a file, but Git could not track it. See, Git knows there is a file, but it is untracked. What you have to do to track it, you have to do git add. Relate to the architectural diagram always. Relate to the architectural diagram. So now tell me, it is asking me to add, means where is the file? I want answers from each and every one of you.
Working directory.
Exactly, it's in the working directory because it's asking me to do git add. So like I said some time back, relate it all of that, whatever I have explained. I'm just writing it quickly so that you can relate. Yeah, what I said, whenever you just create a file, simply create the file means it is said to be in the working directory, right? Then you run the command git add. Then only it's said to be in the staging area. Then you do git commit. Then it's said to be in the local repository. Correct? So now I just created it. Where is it? Working directory. That's why it's asking me to add. So, but see here, physically it's the same directory. Do you notice that? It's in the git demo only. Physically the same folder, but logically they are separate. Okay, it's in working directory. So now what I'll do, git add file 1. So now tell me, where is the file now? Check the architectural diagram and tell me.
Staging area.
Staging area.
Exactly, it will be in the staging area. If you want to confirm, check the status. See, it was not telling you untracked because it was tracking changes to be committed. That's all. To be committed means where is it? Obviously in the staging area. Now git commit. How do you commit? -m is mandatory. M flag is mandatory. M some message like okay first file or something like that. Okay, some message is mandatory. Done. Now tell me, where is the file?
Local repository.
Obviously it's in the local repository. And at this point, if you run the command status, yes, it tells you it is all clean. It's all clean means whatever in the directory were all committed. So do you see that it's the same directory? That's what I mean. Working directory, staging area are physically one and the same. Logically they are different. Got it now? Sounds interesting, isn't it? Interesting, tricky. Yeah. Let us repeat the same with another file so that the flow should be crystal clear for all of you. Shall we repeat?
Yes.
ls will show you the files in the particular folder, whereas git ls files will show the files in the local repository. Okay, because that is in the local repository, it was also listed there. Perfect. Let me create another file. I'm using Vim editor. You may use GUI. It's up to you. So escape I. Let's say this is second file, some dummy line. It could be a program file. It could be some Ansible script, whatever it is. We'll apply the same concepts of versioning to other files in our course. So let's save it. Done. Tell me now, where is this file? File 2?
Working directory.
Yeah, it's in a working directory. Status tells you untracked. Okay, to track it, you have to add. Before that, ls. It was listing both of them. Git ls files. Do you notice the difference? Because file 2 is not yet added to the repository, it was not listed with git ls files. Got the difference, everyone? Yeah. So perfect. It was working as expected. And yeah, let us add this file. Git add file 2. Now tell me, where is this file 2? Obviously, where is it?
Staging area.
Staging area. From staging area, you have to commit it. Git commit -m. Let's say some message. The importance of message we'll discuss as we go by. For now, let's say second commit. Okay, done. Now if you check the status, it should be on. Okay. Clear with the architecture now, everyone? See, please keep muted. There is some background noise coming. Okay, so this is the architecture. Always keep this architectural diagram in your mind whenever you are doing any operations in Git. Okay, you relate to this diagram. Mentally, you calculate where changes are happening with this architectural diagram and learn it. All these commands, this presentation, everything are there in Google Drive, which will be shared with you. Okay, so this is how you work. And till now we have committed twice, isn't it? We have run the commit command twice. So for each commit, what happens is a commit ID will be generated. The complete commit history can be checked with the command git log. See, every commit we have committed twice. So first commit ID, second commit ID. Alphanumeric hash code is generated for every commit which is unique. Okay, and see here, author name, I have given just dummy credentials. Initially, it will prompt for the credentials. Some dummy credentials, date, timestamp. I told you some time back, right? Detailed logging, including the timestamp, is very important. Yeah. So this is the timestamp, so that you know what changes are happening here, right? Also, let's say I don't want to see this elaborative detailed log. I just want a brief log. Git log, one line, a brief log. Yeah, first 6 characters are enough to refer any commit. Okay, you can check the messages with the git show this particular commit ID. Okay, just first 7 characters are enough. When you see, if you want to see what changes happened in, when you do git show the complete commit ID, again the whole timestamp, the changes made, everything will be shown. Okay, so these are the 2 more commands, git log command, yeah, and git log online, one line, sorry, so that to see the brief log. So every commit, what it does, it just generates a commit ID. And one more thing here is, whenever you do git log on one line, you are seeing the history of commits, right? And you will see the commit message. I told you message is mandatory. It will not allow you commit without message. You should be giving here a reasonable message, means a message so that at a later point you can understand what changes are with this, means what changes this corresponds to. Means if I say something like first file, okay, I understand, okay, this committee is doing something with the first file in the repository. So something like give some reasonable name, so that at a later point of time you can understand what these changes are for, right? That's the importance of message. And we have run some bunch of commands, right? Clear will clear the whole terminal. History command will list the complete history, complete commands whichever we have executed. So to just check the complete list, these are all simple commands, clear, history, and so on, right? So that's about the Git architecture, and we have created 2 files. Remember one more thing, we were working on local repository. We didn't go to remote it. Okay, where how to go to remote, what changes you have to do on remote, we'll discuss as we go by. Before going to remote, there are lot many things we have to do here. Okay, then we'll go for remote. We'll do push, pull, clone, lot many things, lot many commands coming up. Conflict scenarios, resolving the conflicts, merges, stash, rebase. Okay, lot of stuff coming up. So let's wait and go in a sequence. Okay, now that till now we have just created new files, isn't it? I just created file 1, new file, file 2 is another new file. What if you want to edit or modify the existing files, isn't it? In a project, always it's not about creating new files. You may have to work on existing files, isn't it? So how to do that? So that's the next scenario. Shall we proceed? Any questions you have here? Are you all with me? Following? Hello, please respond. These are interactive sessions, okay? It should be a two-way communication. That makes our sessions interesting. Don't just keep quiet. If you didn't understand or if you didn't follow, you can feel free to express. Or if it is clear, do express that as well. Understood? Or
Yes.
any question?
I'm good.
Yeah.
Yes,
Thank you.
Yes, ma'am.
Thank you. Okay. All right. Now let's create another, rather than creating a new file, let's see modifying an existing file. Okay, let's suppose I want to work on this file 1. Okay, now I just want to make some modifications here. Escape I. Okay, now here I just want to edit something like new. I'm writing dummy lines. If you are interested, if you are a developer or tester, you can write your any code, or else if you are a ops person, write some scripts. Anything is fine. So just add some line. Done. See, remember always one thing. Git works with respect to changes. Git always works with changes. This change could be creating a new file. That change could be deleting a file. It could be modifying a file, whatever it is. Git works in the same way. It works with respect to the change. The change could be anything. Okay, so now I just made a modification. Again, the same modifications will be in a working directory. You should move the modifications to staging area and then to local repository. Let me show you. Git status. See, but this time it will not tell you untracked because file is already tracked, right? Only changes, not staged, means unstaged changes. Understand everyone? Unstaged changes. If it is a new file, it will tell you like untracked changes. But it's not a new file. Okay, so not a new file. Only the changes, so unstaged. Get the difference between this terminology. You should understand the difference between this terminology, which is very important, because don't get confused between untracked and unstaged. Sometimes we say, okay, unstaged changes are there, you have to commit, or else untracked. Got the difference? Here file is staged, so only certain modifications, they are called unstaged. Yep. There should be clarity in this understanding these terms. Okay, now what you have to do, obviously again, okay, let me 1 minute. Yeah, can you tell me what we have to do now? Again, add and commit. So what you have to do? Git add and then git commit. You have to do this Or else, because it's not a new file, you can add and commit with a single command. Git commit -a means add and commit. You can also do this because it's not a new file. Means for unstaged changes, unstaged means not a new file, you can do this way or else this way. Both are fine. But if it's a new file, you should do only separately. Understood, everyone?
Yes.
Just let me summarize here. If it is untracked file, you have to add and you have to commit separately. Unstaged means not new file. In that case, you can add, you can commit separately, or else you can also do this. Okay, that is also fine, right? So because we did always this, now let us try this with a single command. Git commit -a -m, let's say file modified. Okay, it will add to staging area and then we'll commit it. Check the status. Clean means everything got added, and if you check the log, new commit ID got added. Right? Interesting, isn't it? If you learn this with clarity, you will love working with Git. Yep. So modifications are done this. So just remember one thing, Git works with respect to changes. Whether it is a creating a file or deletion also we'll see. Okay, deletion we'll see, reverting we'll see, we'll do lot many operations on these files. So you first have to put them to staging area, from staging area to local repository. So what is your local repository here? What is your local repository? Git demo is your local repository, isn't it? What is your working directory? The same Git demo is a working directory, correct? So they are same, but logically they are different, as like we have seen. Yeah, then we have the next scenario. Yeah, we can get into the commands of diff. Let me create one more file. I'm just creating another file, file3.txt, escape I. Let's say a new third file, escape : wq exclamatory mark. So file is created. I just want to add and commit. I'm quickly adding. We already learned this. Okay, git add, git commit -m, let's say third file, something like that. Okay, done. Okay, so when you see git status, it was all good. Okay, now let me do one thing. I am modifying this file. This also we have seen, modifying the file, right? I'm just modifying this file3. A new line, saving it. Now, is this file having unstaged changes or not?
Yes.
This file is having unstaged changes or not?
Yes, it is having.
Yes, it's having. Git status will tell you not staged. File3 have changes not staged, means unstaged changes. If you want to see unstaged changes of the file, you can use git diff file name. Unstaged change plus indicates a line is added, which is unstaged. Okay, that's another diff command to check unstaged changes of the file. There are many things you can do with it. We'll talk about them. Before that, there were few questions. Let me take up the question from Harish. Codes are printed, but we have created 2 files only, but modified it right. Whenever you commit, then only a new commit ID will be generated, Harish. Commit IDs are not corresponding to the number of files. Okay, whenever you run commit command, commit ID is generated. We have committed thrice, so 3 commit IDs were shown. 2 files only, but I have modified the file and made another commit. Understood? See,
Oh, yeah, okay.
these, yeah, tell me.
Yeah, understood.
Okay, commit IDs happen whenever you run the commit command. You may make modification, commit any number of times on the same file. So those corresponds to the commit IDs, means commit commands you run. Okay, so this is another command to check the unstaged changes of the file. Okay, then I'm staging it. Git add file 3. Now tell me, is this file having any unstaged changes now? Hashmi, Sirisha, Shravani, everyone. Is this file having any unstaged changes? Understood my question? Is this file having any unstaged changes now? I just have added. Is it having any
No.
unstaged change now?
No.
Obviously, there are no unstaged changes, right? Not unstaged. Okay. So at this point, if you check git diff file name, no output because it doesn't have unstaged changes. Only staged changes are there. If you want to see the staged changes of the file, git diff staged. Okay, staged changes because the same line is staged now. Those are simple diff commands. You can use diff command in multiple other ways also. We shall execute other scenarios in the next class. This is enough for today. Any questions, let me know. So see, as an assignment today, as a homework, install Git. First of all, you have to get ready with your lab. So install Git on your Windows. It is a very lightweight tool. You can just install it on any normal PC will do. Install it on Windows, launch your Git bash, try to use the command line and learn these commands this much. This is enough for today. If you are ready with this, you can get started with the other concepts in the next class. And I'll be sharing you the recording and also the Google Drive, which have all this commands list, everything. And one more thing, 2 demo sessions were done. Whoever want to continue from tomorrow, you can reach me on my number and confirm, enroll, complete your enrollment and join from tomorrow. Whoever enroll will be providing with this access. Any more questions? Let me know, please. Any questions, any concerns, any doubts, anything?
So Preeti, you are going to provide a commands list, Git commands
Yes,
list?
I'll be providing you the command list. Please confirm me on the WhatsApp.
Yeah, Preeti.
Whoever completed enrollment process, enrolled, all of you will get the email link.
Yeah, Preeti.
Only one person, please unmute and speak up. Yes,
Yeah,
Parthi,
Preeti, you
please.
showed something Google Drive. Can we access it directly, that Google Drive?
I'll provide you the access. Okay, whoever completed the enrollment process, I'll provide the access to them after the class. Some of you already have provided. Whoever have enrolled this morning, you will get access after the class.
Really, sorry, I joined little late. Is there anything I have to fill? The form or
Reach me on
something?
WhatsApp, Shiva. Okay, reach me on WhatsApp. I'll help you with the process.
No, I thought so. Already you explained.
Yeah, Preeti.
Tell me, please. Hello.
Yeah, Preeti, may I audible?
Sorry?
Yeah, my voice is clear, right, for Preeti?
Yes, tell me, please. I can hear you.
Yeah, Preeti. Will you provide any theoretical, because we teach it, right, that architecture something and all. Will you provide any theoretical notes, kind of
For the
Documents.
command explanations, Guru will be provided. For the rest, the recording will be provided.
No, combines wise, the theoretical part I'm asking about that.
No, theoretical documents will not be provided. Recordings will be provided.
Okay. The definition kinds that VCS something you told, right? So that kind of
Presentations will be provided. Definitions, theoretical notes will not be provided. And Harish, please reach me on WhatsApp. Okay. If you have any questions regarding payment, reach me on WhatsApp.
okay.
So that is all from my end. Thank you. Thank you all for joining. Any more questions, anything else you have, reach me on my number. And that's all for today. Okay, we'll close here and continue tomorrow.
Yeah.
Bye.
Thank you, Preeti.
Thank you all. See you all tomorrow.
See you. Thank you.